Hello and welcome to College Algebra 5.4, all about exponential and logarithmic equations. So we're going to start solving today, or we touched on that a little bit in 5.3, but we're going to expand on that concept. So here, one thing we need to remember is switching forms. I always call it spiraling, where you start from the bottom and spiral out, so you get b to the y equals x. Remember that the implied one for natural log is an e, so the exact same idea works there. Otherwise, if I had something like that, I can just do that there. So you can think about it as 5 squared equals x minus 3. Well, 5 squared is simply 25. And then we can add the 3 and get x equals 28. The other way of thinking about that is understanding that something like b to the power of log base b simplify out and undo each other. So if I do 5 to the power of both sides, this gets canceled, so I get x minus 3 equals 5 squared. Well, 5 squared is 25, and there I get the exact same process at the end of x equals 28. Okay. Now, that same logic applies in reverse. I can, of course, recognize that this can be spiraled the other way, where base b of x equals y. And same thing with natural log, I would just be using an e instead. So here I could spiral this. So log base 3 of 9 equals x minus 4. And I could either type log base 3 of 9 in my calculator. So remember that'd be, not math, be math A for log base. Log base 3 of 9 equals 2, x minus 4. Or we could recognize that, just from yesterday, this 9 can be written as 3 squared, and log base 3 of 3 squared, these two cancel out, and that just equals 2, which is exactly what I got right there. From there, we can add 4. So we get x equals 6. Okay. So that's the idea of spiraling it. Otherwise, we can use this inverse relationship, this idea that functionally what we get right here, where log base b of b, so if I just did log base 3 of both sides, and these 3's cancel out, I'm left with x minus 4, and over here, again, log base 3 of 9, as we discussed earlier, was 2, and we get x equals 6 same way. This one has a secret third option you could do, and it's just because how the way that 9 and 3 interact. Well, we just discussed earlier that 9 is the same thing as 3 squared, so I can replace the right-hand side with 3 squared, and if these two have the same base number, their exponents have to also be equivalent values as well, so we get the exact same spot of x equals 6. Okay. I don't mind whichever strategy you do. People tend to gravitate to the spiral, but if you want to think about it in any of these ways, that's fine. Just remember that this third one only works sometimes. Like, for example, there's no way I can rewrite 17 as 3 with an exponent. So spiral it, so we get log base 3 of 17 equals x, and the nice thing is that's all just numbers. I can type that whole thing right into my calculator. So math A, log base 3 of 17, we get x is about 2.58. Okay. Over here, there's no number written, so remember it's implied to be a 10, so I can spiral it. So we would get 10 squared equals x squared. Well, then x just has to be 10. Okay. Here, we can't spiral it yet. You have to divide by 20. You have to get whatever has the exponent by itself first. So I get 1/2 to the power of x over 3 equals, I'm going to write this as 1/4. And from here, you could spiral it or recognize that 1/4 is the same thing as 1/2 quantity squared and replace it, but either would get you the same spot. We get x over 3 equals 2, just by typing that in, times 3, we get x equals 6. Here, same idea, whatever has the exponent has to get by itself first, so I'm going to minus 5, so e to the 2x equals 35, and then I'm going to spiral. But remember, if I'm spiraling with e, that's going to be a natural log of 35 equals 2x divided by 2, which I can type this whole thing right into my calculator. Natural log 35. Let's make sure we close the parentheses before we hit divide, and we get about 1.78. Okay. Here I am adding, so remember for condensing earlier, so I'm adding, so which means I have to multiply the insides. Equals, and I'm going to put this 2 up top. So from the power rule, so x squared. So I'm going to have to FOIL these. So 3x times x is 3x squared. 3x times -1, -3x. -2 times x, -2x. -2 times +1, +2. Combined like terms, we have the natural log of 3x squared minus 5x plus 2 equals the natural log of x squared. Well, we can e to the power both sides and get rid of those natural logs. So we get 3x squared minus 5x plus 2 equals x squared minus x squared minus x squared. We have 2x squared minus 5x plus 2 equals 0. From there, we can just simply factor it in whichever way you feel comfortable. For the sake of time, I'm going to tell you that your potential solutions are 2 and 1/2. Now, quick side note, we have to remember that when we're doing stuff like y equals the natural log of x, and I graph it, we get something like this because our domain is 0 to infinity. If we go back a couple chapters, we have to remember that this value has to be greater than 0. It can't be negative, and it cannot be 0 exactly. Well, if I were to plug in -2 into one of my logarithms, for example, it doesn't matter either the first one. Let's do it for the first one. Natural log of 3 times 1/2 minus 2. 3 times 1/2 is 1.5. 1.5 minus 2 gives me the natural log of -0.5. So I already know that 1/2 can't actually work. It's an extraneous solution that gets created. It would actually be extraneous for this one as well. 1/2 minus 1 would be negative as well. So my only answer would be x equals 2. Now, of course, you might get some problems that are too complicated to solve that way. But in general, you'd want to get one logarithm total, or at least just only one on each side if they have the same sort of structure and same base. You cannot solve it from here, so that's why we had to condense it right there. However, something like this, e to the x minus e to the negative x, there's really not a lot you can do. So what I would recommend is graph one of them in one equation, 1y, so y1, and put the other one in y2 and try to find the intersection, more specifically the x value. So yeah, type it into my y equals, which I have here, and hit graph. Now, a lot of these features are under second in calc. This one I'm going to pick is intersect. So second calc, I'm going to pick 5 for intersect. Arrow keys help determine. So first curve, I just need to make sure I'm on one of the equations. You see my little cursor is blue. you're on the blue line, and you can see because it's up here, y1 is blue, and I'm on a blue coordinate. So if I'm on one of the curves, I'm going to press enter. It should automatically switch me to the other one. Now it's all red. I could hit enter here. If I had multiple curves, I could alternate with the up and down arrow keys. I just need to make sure that first curve, second curve, I'm picking two different ones I want to compare. And then guess, I want to get as close as I can to whatever intersection I'm trying to find. This only has one intersection, so I don't need that part. But if it had multiple intersections, that would help direct the calculator. And here I get that exact same answer. The other way you could do it is you could see how these are equal to each other. You could subtract 5 from both sides. So now you have e to the x minus e to the negative x over 2 minus 5 equals 0. And then you could just simply look for the x-intercept if you wanted to do that way. Either one would work out. It all works. Okay. All right. You invest money into an account with 5% interest compounded continuously. Whenever you see compounded continuously, you have to use this equation right here with the PERT. If it didn't, and it would say like compounded monthly, daily, something like that, you would use A equals P, parentheses, 1 plus R over N to the power of NT. Well, we have a lot of similar variables. So let's account for them. A is your amount at the end. P is what's called your principal, or how much you start with. That's a bad S. I didn't know if I want to do parentheses or an S. Let me fix that quick. Okay. R is your interest rate, but it is as a decimal. T is time in years. And N is number of yearly compounds. So if it said, compounded monthly, well, there are 12 months in the year, and it would be 12. And so we have 5% interest rate, so R is going to be 0.05. Okay. How long will it take you to double your investment? Well, I don't know what my investment is, so for the sake of argument, I invest X. If I'm talking about doubling my investment, A would have to equal 2x because it has to be double. So I get 2x equals x e to the 0.05 t, because I'm solving for t. How long? Well, I can divide both sides by x. So actually, it turns out it doesn't matter what my investment was, because at the end of the day, I was going to end up with 2 anyway. And I want to get rid of the e, so I can spiral it or natural log both sides, however you want to think about it. And then divide by 0.05. So on my calculator, I can just type natural log of 2 divided by 0.05. So it would take about 13.9 years. Thank you for listening, and I hope you have a wonderful day.